Welcome back, everyone. Thank you for watching my video today on an introduction to polynomial functions. As you open the notes here, I hope you notice there's a warm-up problem there from our unit on transformations. Please pause the video and try that opener to the best of your abilities. Come back and unpause the video to check your answer when done. All right, here is what you should have got for our opener. You can see my blue is the dashed quadratic function. That would be our parent function, y equals x squared. Oops, sorry about that. Y equals x squared. And then the red is the transformed function with three transformations: a shift left, a shift down, and a vertical compression. All right, so today we're going to talk about polynomial functions, and we're going to begin our adventure in graphing these polynomial functions. Now, obviously, we've already done a little bit of this. We've graphed some quadratics, but what if it's a higher power than 2 or 3? We have a fourth or fifth or sixth power polynomial function, okay? For example, here we see a third power polynomial function. So, first of all, the degree. The degree is very important to notice what we have here. So the degree is the highest power that we see on a variable here. So the degree of a function, we call it n, okay? But it's just the highest power of, in this case, x. So we'll go highest power of x. All right, if you look over here, the highest power on a term with x in it is 3, so our degree is 3. That number is the same amount of number that a polynomial function can have for zeros. Okay, so a polynomial function can have at most n zeros. It will actually have n zeros, but whether they're real or imaginary, we don't know until we actually do the work. Okay, so how many real zeros could it have? Well, it could have 3, or it could have 1, or it could even have 2 different ones, but we won't know that until we actually go through the solving. So in this case, at most 3, but it could be less than 3. The number of turning points on a graph, so we call those local maxes or local mins, is going to be n minus 1. Okay? So in this case, it'd be 3 minus 1, which is 2. So we're not actually graphing today, but when we start doing our graph soon, you'll see that this graph will have at most 2 points where it turns and goes the other way. Okay? So let's take a look at a couple of these and see some good information about each one. So we're just going to ask ourselves, is this polynomial or not? If it is not, let's talk about what kind of function it is. And if it is, we'll answer all the questions that follow. So here's our first one, f of x. Is this polynomial? Is it in this form? And the answer for this one is a resounding yes. So write it in standard form. Standard form just means to multiply it all out if necessary, which there's nothing to do here. But then also to write it in descending degree order, like so. So now we can see the degree clearly is right there. The degree is 3. The leading term is negative 4x cubed. What is a leading term? It's just the first term in standard form. Okay? Now, if I said leading coefficient, the leading coefficient would just be this number right here, negative 4. Okay? But if I want the leading term, it's negative 4x cubed. The constant term is the term that doesn't have an x with it. So in this case, it'd be negative 4 also. It's just a coincidence. Sometimes there is no constant term, so you would just put 0 for that one. So what we just learned in the last slide, what is the maximum real zeros it can have? Well, it's equal to the degree, so this case would be 3. The maximum amount of turning points would be 1 less to the degree, so that would be 2. Example 2, is this polynomial or not? This one is, in fact, polynomial. Write it in standard form. That's going to require us to do a little bit of multiplication, so 2x squared minus 8x plus 3x minus 12. And you could have skipped that step and went right to here, 2x squared minus 5x minus 12. That is standard form. So our degree, so if you look at this, you might think the degree is 1, but that's not actually true. Even though this is the first power and this is the first power, if we multiply that out, to get our degree, we want to think if we multiply it into standard form, what would be the highest power of x? So that would be 2. What is the leading term? 2x squared. What is the leading coefficient? That would just be 2. And what is the constant term? That would be negative 12. The maximum numbers of real zeros we can have, that's the same as a degree, so 2. And the maximum number of turning points this graph could have, that would be 1 less than the degree, so that would be 1. Number 3, is this polynomial or not? This is not polynomial. Why? It's a fraction with a variable on the top and the bottom. That means this is going to be a rational function. So we don't got to worry about answering any of these questions here because they don't apply the way to rational functions the same way they do to polynomial functions. All right, our last one here, is this polynomial? First of all, yes, this is polynomial. If we multiply it all out, it would be in the form that we talked about earlier today. So it says to write it in standard form. All right, this is going to be some work here. First, I'm going to distribute that x into the x squared, the x plus 2. And then the x minus 1 squared is x squared minus 2x plus 1. All right, and then we got to multiply all that out as well. So h of x is going to be x to the 4th minus 2x cubed plus x squared plus 2x cubed minus 4x squared plus 2x. Now, combining like terms and writing it in descending order, we get x to the 4th. The 2x cubes cancel, minus 3x squared plus 2x, and I forgot my plus 1 here. Oh, never mind, that is correct. We're good there. Okay, so x to the 4th minus 3x squared plus 2x is our function h of x in standard form. What is the degree? Again, you want to look here, the degree is 4. How could we have got the degree from looking at this? This is x to the 1st, this is x to the 1st, this is x to the 1st squared, so it would be x to the 2nd, right? So we have x times x times x to the 2nd, which is x to the 4th. So you can actually get the degree from it not in standard form. But now we have it in standard form, so let's use that. The leading term would be 1x to the 4th. The leading coefficient would be 1. The constant term, there is none, so it would be 0. The maximum real zeros would match the degree, so 4. The maximum amount of turning points would be 1 less than that, so 3. Okay, that is it for our introduction to graphing polynomial functions. Next week, we'll actually start looking into graphing them. All right. Thanks again for watching our video today, and we'll see you again soon.